Hi, welcome back to our channel. Today we are going to discuss definite integration continuation problems also. Continuation problems. This chapter having seven marks important problems. 8 problems. Already can do 6 problems is over. This video 7 and 8 problems. Can do 7th and 8th problems. This one also same as to it. Before videos can apply same property. Integral 0 to a f of x dx equal integral 0 to a f of a minus x dx. Okay, let I equal integral 0 to pi x sin x by 1 plus cos square x. This is the given problem. First of all, we can take I equals to given problem. Next, apply the property. Integral 0 to a f of x dx equal integral 0 to a f of a minus x dx. That equal 0 to pi. Here, upper limit equal to pi, so we can write x by pi minus x, and same as pi minus x by 1 plus cos square pi minus x, upper limit minus x. Okay, already we know that in above problem also we can do this one. Sin of pi minus x equals sin x and cos of pi minus x equal minus cos x. But here cos square, so minus of cos x whole square is also positive. So integral 0 to pi minus x sin pi minus x is can write sin x by 1 plus cos square x. Next, multiply these two terms. Integral 0 to pi sin x minus x sin x by 1 plus cos square x dx. That split into two terms. Integral 0 to pi sin x by 1 plus cos square x dx. Integral 0 to pi x sin x by 1 plus cos square x. X sin x by 1 plus cos square. You can observe this step. This is also given problem. We can take I. So this step that equal pi is also constant. 0 to pi sin x by 1 plus cos square x dx minus I. So I plus I to I equals to pi integral 0 to pi sin x by 1 plus cos square x dx. In the above problem, here sin cube x by 1 plus cos square x. This problem sin x by 1 plus cos square x. In above problem sin cube x is there, then sin cube x we can write sin square x into sin x. Sin square x equals to 1 minus cos square x. In this problem we cannot write that type of the problem. This is only simple problem is there. Cos x equals to t, derivative of cos x minus sin x dx. Okay, so same as in the above problem, cos x equals to t. Let cos x equals to t, derivative of cos x minus sin x dx equals to t. Whenever we can do this problem in type of substitution method, immediately we can change the lower limit and upper limit. So change the lower limit. X equals to 0, that equals to t equals to cos 0 equals to 1. Upper limit x equals to pi. Here x equals to pi, t equals to cos pi is equals to minus. Okay. Therefore, 2I equals to pi integral 0 becomes to 1 pi becomes to minus 1. Sin x dx equals to minus dt by 1 plus t square. Okay, already I told you lower limit and upper limit change in above problem also. This one is also same. Problem is there. Pi integral changing the lower limit and upper limit, minus becomes to positive dt by 1 plus t square. This is the formula of integral 1 by 1 plus t square dt equal tan inverse of t. Already you know that, and tan inverse of t. You can apply this formula, pi into tan inverse of t integral minus 1 to 1. Apply the lower limit and upper limit, tan inverse of 1 minus tan inverse of minus 1. Okay, minus tan inverse of minus 1 equals to minus of tan inverse of 1. Already minus or minus plus tan inverse of 1. Okay, tan inverse 1 plus tan inverse 1 equal to 2 tan inverse of 1. 2 tan inverse of 1. That equal to 2 pi tan inverse of 1 is the value of tan pi by 4. 1 is the value of tan pi by 4. Tan inverse tan is get cancelled. That equals to 2I equals to 2 pi into pi by 4. Okay, 2 is get cancelled pi by 2. That equals to pi square by 2. 2I equals to. That implies I equals to pi square by 2 into 2 equals to 4. This is the final answer. You can observe in the above problem and this problem is the same, a small difference from this step to this one. These are all steps are already, you can do the before problem also, but we can apply this property. 0 to f of x dx integral 0 to f of a minus x dx. By using this property, this step is over, this step is over. The next step is split into two parts. This part is also given problem. We can take this URL is equals to I to I equals to. Okay, this is cos x equals to t. Immediately we can change lower limit and upper limit, and the lower limit is least, upper limit is greatest. In here there is no lower limit is least, upper limit is greatest. So first of all, changing the lower limit and upper limit, this is the formula of tan inverse of t. So integration is over. Next we can apply the upper limit and lower limit. We can find the final answer is there. The last problem of this chapter. I will do it. The last problem of this chapter. Integral 0 to pi by 2 sin square x by sin x plus cos x dx. Sin x plus cos x dx. Out of 8 problems, this property is useful for all problems, all essay questions in this chapter. So let I equals to same. Let I equal 0 to pi by 2 sin square x by sin x plus cos x dx. Next, you can apply the property 0 to a f of x dx equals to integral 0 to a f of a minus x dx. Upper limit equal to pi by 2. So 0 to pi by 2 sin square x means pi by 2 minus x by sin pi by 2 minus x plus cos pi by 2 minus x. Already we know that sin 90 minus x equal cos x, cos 90 minus x equals to sin x. So sin 90 minus x equals to cos x. here cos square x by sin 90 minus x cos x plus cos 90 minus x sin x dx. In above problems, we can apply this property immediately changing split into two parts. But in this problem, we cannot split into two parts. So, in this way, this is equation number 1, this is equation number 2, adding 1 plus 2, adding 1 plus 2. Okay, I plus I, left hand side 2I equal to, right hand side same integral 0 to pi by 2 and also same denominator also, same denominator. Okay, so denominator is also same. Can adding the numerator only, adding the numerator only, cos square x by cos x plus sin x dx. Observe this step, sin x plus cos x or cos x plus sin x is equals. So denominator is equal, so we can adding numerator only, sin square x plus cos square x by sin x plus cos x, sin x plus cos x dx. We know that sin square x plus cos square x equals to 1. This is the trigonometric identity. Sin square x plus cos square x equals to 1. Can apply this formula, that equals 0 to pi by 2 1 by sin x plus cos x dx. Already we know that in indefinite integration model number 1, indefinite integral model number 1 by a plus b cos x or 1 by a plus b sin x or 1 by a cos x plus b sin x or 1 by a cos x plus b sin x plus c, b sin x plus c. This is model number 1 in indefinite integral. Already can do these problems. You can take tan x by 2 equals to t. Okay. Can take tan x by 2 equals to t. Put tan x by 2 equals to t. This is also a substitution method. Now immediately you can change the lower limit and upper limit. Tan x by 2 equal to t, differentiate secant square x by 2, inner derivative x by 2 equal 1 by 2, dx equal to dt. So, dx equal to 2 dt by 1 plus t square, 2 dt by 1 plus t square. Next, sin x equals to 2t by 1 plus t square, cos x equals to 1 minus t square by 1 plus t square. Then change the lower limit, x equals to 0, t equals to tan 0 by 2 equal tan 0. Tan 0 is equals to 0. This is lower limit, t equals to 0. Next, upper limit, x equals to pi by 2. Upper limit, x equals to pi by 2. Can apply t equal tan pi by 2 by 2 tan pi by 4 is equals to, already we know that 1. Okay. Therefore, 2I equals to 0, lower limit becomes 0 and upper limit becomes 1. Dx is equals to, already write in the above step, 2 dt by 1 plus t square by sin x equals to 2t by 1 plus t square, cos x equal 1 minus t square by 1 plus t square. The next step, that equal to integral 0 to 1 2 dt by 1 plus t square, LCM of these two terms is also same. So we can take 1 plus t square. In numerator is also we can adding only 1 minus t square. Can observe 1 plus t square is get cancelled, that equals to remaining term 2 dt by minus t square plus 2t plus 1. This is also we have to learn in above chapter. This is model number 1. 1 by quadratic expression. 1 by quadratic expression. This is the adjustment. This is the adjustment integral 0 to 1 2 dt by minus is the common t square minus 2t minus 1. T square minus 2t minus 1. That equal integral 0 to 1 2 dt by minus of t minus coefficient of t equals to 2. 2 by 2 is equals to 1. So we can write 1 whole square. Always minus. In this 1 square equals to 1. Remaining only minus 1. So minus is the common. That is adjustment. That equal integral 0 to 1 2 dt by minus of t minus 1 whole square minus 1 minus 1 minus 2. Minus is the common, so multiply with minus. This can change 2 minus t minus 1 whole square. We can apply the formula 1 by a square minus x square, but 2 is, there is no square. So small adjustment 2, we can write root 2 whole square minus t minus 1 whole square. Now we apply the formula 1 by a square minus x square dx. 1 by a square minus x square. That equal 1 by 2a log modulus a plus x by a minus x. A plus x by a minus x dx plus c. Can apply this formula 0 to 1. 1 by 2a. 2 is the constant. 1 by 2a. A is equals to root 2 log of 1 by 2a. Log modulus a plus x. A means root 2 plus t minus 1 by root 2 minus of t minus 1 minus t plus 1. Now apply the lower limit and upper limit. This problem is over. That equal 2 is dead cancelled. The final 2i is equals to 1 by root 2 overall bracket log of lower limit 1 root 2 plus 1 minus 1 by root 2 minus 1 plus 1. Next apply the upper limit 0 root 2 plus 0 minus 1 by root 2 minus 0 plus 1. Minus plus 1 minus 1 plus 1 is dead cancelled. 1 by root 2 log of modulus root 2 by root 2 is the remaining term minus log of root 2 minus 1 by root 2 plus 1. Root 2 is dead cancelled. That equals to 1 by root 2 log 1 minus log of root 2 minus 1 by root 2 plus 1. Okay. That equal log 1 is equals to 0. Since log 1 equals to 0, so this term is equals to 0. 1 by root 2 minus of log of root 2 minus 1 by root 2 plus 1. Now remove the minus, the interchange the reciprocal of these two terms, minus is cancelled. So root 2 plus 1 by root 2 minus 1. Now that equal 1 by root 2. Rationalization of these two terms. Root 2 plus 1 by root 2 minus 1 into root 2 plus 1 by root 2 plus 1. That equal 1 by root 2 log of root 2 plus 1 whole square. Root 2 plus 1 whole square by a plus b into a minus b. 2 minus 1 is equals to 1. So log of a power of m equals to m log a. That equal 2 by root 2 log of root 2 plus 1. But here 2i. Now cancel these two i's, 2's. That equals I equal 1 by root 2 log of root 2 plus 1. This is the final answer. Okay. This problem is over, and into the indefinite integral and definite integral essay questions all are over. Now we are going to the next video in circles. Okay. Thank you very much to all. మీరు అలాగా చూస్తూ ఉండండి. నెక్స్ట్ సర్కిల్స్ అనే చాప్టర్ అని చేస్తాము. మనము 1Aలో 2 or 3 టాపిక్స్ చేసాము, 2Bలో 2 టాపిక్స్ చేసాము, 2Aలో 2 టాపిక్స్ చేసాము, అలాగే 1Bలో 2 టాపిక్స్ చేసాము. నెక్స్ట్ అనేది కంటిన్యూ చేద్దాం. ఎస్సీ క్వశ్చన్స్ అయిపోయిన తర్వాత 4 మార్క్స్ కూడా మనం ఇలాగ చెప్పుకుంటూ పోతాం. మీరు చూస్తూ ఉండండి. థ్యాంక్ యూ వెరీ మచ్ ఫర్ కోఆపరేటింగ్ దిస్ ఛానల్.